Okay, we're going to finish this section with a talk on percentiles and the applications of percentiles. We did talk about percentiles earlier in the semester. In Chapter 3, we looked at percentiles, and we discovered that the percentile rank of a data value x indicates the percent of data values within a distribution that are less than the data value x. So let's look at a real example. If, for example, we're talking about data value x representing children's heights, let's suppose we're looking at a certain age group, and we're told that the percentile rank for 48 inches is 90%. What that means is that 90% of all the other heights in that distribution are less than 48 inches. In a normal distribution, the percentile rank of data value x is equal to the percent of area under the normal curve to the left or below the data value x. So suppose that we have raw scores labeled on the horizontal axis from least to greatest. And suppose data value x, or maybe 48 inches, whatever raw data we're representing, is labeled right here. The percent of area to the left of that raw score represents the percentile rank of that raw score. It's basically the percent of values within the distribution that are less than that raw score. And that is the definition of a percentile rank. We're going to always express a percentile rank as a whole number. So this is one of the different things about percentile ranks. When we find a proportion of area on our calculator, we know that it gives us a proportion as a decimal, less than 1. To turn it into a whole number, we're going to first multiply it by 100 to turn it into a percent, and then we're going to round it to the nearest whole number. So let's look at an example. Matthew earned a grade of 87 on his history exam. If the grades in his class were normally distributed, so this is what makes this question different than a Chapter 3 question. If we're told it's normally distributed, then we know that we can use normal CDF in this problem. The mean is 80 and the standard deviation is 7. Find Matthew's percentile rank on the exam. So to find the percentile rank, we simply need to find the area to the left of Matthew's score. The area to the left of Matthew's score will give us the proportion of class grades that were less than Matthew's. So the percentile rank of data value x equal 87 is equal to the percent of area under the normal curve to the left, which means less than or below the data value x equal 87. So in our normal distribution, we're told that the mean is 80, the standard deviation is 7. Mean is 80. Standard deviation is 7. Matthew scored more than the mean, so his value is on the right side of the mean. So we make a vertical line representing the point where Matthew's score is, and the area to the left of Matthew's score is basically the percent of students or percent of grades that were less than 87. If we can take that percent of area, turn it into and round it to the nearest whole number, that will give us the percentile rank for 87. The percentile rank of area will be the percent of area to the left of 87 and round to the nearest whole number. So we go to our calculator to find the percent of area to the left of 87. So we should note that the lower score that we enter in our calculator is, this is incorrect, sorry. Just should be negative 100,000 for negative infinity. The upper score is positive 87, the mean is 80, the standard deviation is 7, and we get an area of 0.8413. So let me just correct this real quick. This should be negative 100,000. Okay, so the proportion of area is 0.8413. To turn this into a percentile rank, we simply have to turn it into a percent, 84.13%, and then round to the nearest whole number, which is 84. So we're going to follow normal rounding rules. Round to the nearest whole number. So to put into words what we just found is the percentile rank for Matthew's grade 87 is 84. It's a little hard when you put it in this, when you phrase it like this, it's hard sometimes to recognize which one is the score and which one is the percentile rank, but you'll get used to it with practice. 87 is the score, and approximately 84% of all the grades fall at or below 87. So its percentile rank is 84. We could also use percentile notation. P with a subscript 84 means the percentile rank is 84 for the data value 87. So data value 87 has a percentile rank that is 84. Okay, what this means is if the percentile rank of 87 is 84, then the score 87 is the 84th percentile. The score 87, which is Matthew's score, is the 84th percentile, which what we know from Chapter 3 means that about 84% of grades were at or below 87. Approximately 84% of the students had scores less than or equal to the score 87. Try example 7.10. Miss Brooke took 2 exams last week. Her grades and class results were as follows. Okay, on English, she got an 83. The class mean was 80. The standard deviation was 6. On math, she got a 77. The class mean was 74. The standard deviation was 5. Assuming the results of both exams to be normally distributed, which basically tells us that this is different from Chapter 3 because we're using the normal distribution and therefore the bell curve and normal CDF, use percentile ranks to determine on which exam Miss Brooke did better relative to her class. So we're going to calculate the percentile rank for each of her grades, and once we find the percentile rank, the one that is higher will be the one in which Miss Brooke did better relative to her class. Okay, so if you want, pause the video, find the 2 percentile ranks for 83 and then for 77, and then decide which one she did better relative to her class. To find the percentile rank of the English exam, we calculate the area to the left of the raw score 83. So this is what our picture looks like. In the center, we have a mean of 80 and a standard deviation of 6. 83 is to the right of 80, so we label it here. We make our vertical line and we shade all the area to the left of 83 because that is the meaning of a percentile rank. It's the area to the left of the score. So on our calculator, to find the area to the left of this score, we have to use normal CDF with a negative with a lower value of negative 100,000. Oh, again, I messed this up. With a lower value of negative 100,000, an upper value of 83, a mean of 80, and a standard deviation of 6. Okay, so putting those 4 values in, you should get a value of 0.6915, which is 69.15%, which converts into a percentile rank of 69. The percentile rank of 83 is 69. It means that approximately 69% of the students scored at or below an 83. Now, to find the percentile rank of the math exam, we calculate the area to the left of the raw score 77. So this is a different picture. We have a different mean and standard deviation because we're looking at a different distribution of scores. This is the math class. So a mean of 74, a standard deviation of 5. 77 is on the right side of 74. So we make a vertical line and we shade all the area to the right of to the left of 74. Sorry, to the left of 77. This area to the left of 77 represents the percent of area that is, or the percent of grades that are less than 77. So we're going to go to our calculator to find out what that actual percent is. The lower value is negative 100,000. The upper value is 77. The mean is 74. The standard deviation is 5. And so we get 0.7257 on our calculator, which converts to 72.57%. That is about a 73 when rounded to the nearest number. So the score 77 has a percentile rank of 73, which means that about 73% of the students scored at or below a 77. So now let's recap our findings. The percentile rank of 69 for the English grade means that 69% of the score of the class scored at or below Miss Brooks' score. The percentile rank of 73 for the math exam means that 73% of the class scored at or below Miss Brooks' score. So looking at which one has the higher percentile rank, 69 or 73, 73 for the math grade means that the math grade, because it has the higher percentile rank, is the grade that's better relative to the rest of the class. Okay, so that concludes the lecture on percentiles and percentile ranks. So what you want to take away from this lecture is that percentile rank is found by looking at the area to the left of a particular raw score. So you're going to start at negative infinity, then go up to the raw score, and then put in the mean and the standard deviation, and that will give you a proportion of area. You'll convert that proportion of area to a percent and then round to the nearest whole number, and that will give you the percentile rank. Any percentile rank that is higher is the one that is better relative to the rest of the class. Okay, so we've discovered how to use INV norm today, and we did a little bit more with normal CDF using real raw scores and real-world applications. So if you have any questions, please email me. I'll see you at the next lecture.